Today we're going to talk about integration by parts. This is chapter 8, section 2. And so we'll finally be able to take the integral of a product when where u substitution wouldn't work out. So take a look at this first example before we get into the formula. I have the product of two functions. I have 2x and e to the x. Now, if u substitution were to work, I would typically let u equal x, du would equal dx, and somehow I would have a way to get rid of this 2x. If this were e to the x squared, then u substitution would work, but it's not. So since u substitution fails in this case, I need another method. This is basically the product rule for integrals. We start with what we know. So we do know a product rule for taking derivatives of a product of two functions. So if I want to take the derivative of u times v, that would be the first function times derivative of the second, plus second function times derivative of the first. So that's the product rule. And then since all of these have a denominator of dx, I could multiply by dx and cancel those out. And then I could also take the integral of every single term. When you take the integral of the derivative of u times v, you're left with just the u times v, since derivatives and integrals are inverse operations. And then this remaining piece stays the same. You have the integral of u dv plus the integral of v du. Now, we're not usually trying to solve for uv. We're usually trying to solve for the integral of u times dv. So if I take this term and isolate it by subtracting that integral to the left side, I have my formula for integration by parts. So this is integration by parts. It's a formula you need to memorize. And I memorize it by saying, so I've got the integral of u times dv. I memorize the right side. I read it as uv minus the integral of voodoo. I know that's not quite correct, but that's how I read that. Uv minus the integral of voodoo. I know there's an extra vu in there, so don't get confused by that. But whatever you need to do to memorize that formula. We are going to learn a shortcut method in a minute. And so it's easy to forget what this formula is, but you do need to memorize it because there could be multiple choice questions where the answer is in this form, not the form of our shortcut method. Okay, so what are we talking about? We say we have the integral of u times dv. That just means that you have the integral of the product of two functions, and we have to decide which one are we going to call u and which one's going to be dv. It's not always that the first one is u and the second one's dv. So now I'm not sure if you have this on your blank notes, but I want to ignore that statement. Instead, I want to pick u based on the idea of Liate, Liata. That stands for natural log, inverse trig, algebraic, trig, exponential. What am I talking about with that? Well, when you're deciding which function is u and which one is dv, u should be picked based on this order. If there's a natural log in the problem, then u has to be the natural log. If there's an inverse trig, u should be the inverse trig. If there's an algebraic expression like this one, 2x is algebraic, like think linear, quadratic, high degree polynomial, whatever, then that should be u. If there's just regular trig, like sine, cosine, tangent, that's u. Or finally, your last choice for u would be an exponential. So I have an algebraic and an exponential. Algebraic comes before exponential in the Liate idea. So I'm going to let u equal the algebraic expression 2x, and dv is going to be the e to the x dx. dv always gets the dx. I always write these side by side like this, and then underneath u I write du is equal to 2 dx. Now, when we first were doing like u sub, I kept writing du dx equals 2, and then maybe I'd multiply that dx over. So just to save some writing, that's why I'm skipping that step and getting right to it. From dv, we want to find v, and we find v by integrating both sides. So the integral of dv is v. The integral of e to the x dx is e to the x. All right. Now this formula says u times v. So if you set it up like this every time, it's going to be this expression times this one, u times v, minus the integral of v times du. So I always make this little connection to myself just as a visual. But again, this integral is equal to u minus the integral of voodoo. So 2x e to the x minus the integral of 2e to the x dx. I tend to move my integrals out in front, but I don't think I'm going to write a separate step for this one. So since it's just e to the x, this integral should be something you can solve. And if it's not, we'll talk about that in a minute. So this is one I can do without having to do integration by parts again, because it's just a constant and a single function. So the first term comes down, 2x e to the x minus 2. The integral of e to the x is e to the x. This is an improper integral, so when you're finished with everything, that's where you can throw in your plus c. All right. Now, there is a shorter method. It's called the tabular method. Basically, the tabular method is like, has the same relationship as like synthetic division to long division. Synthetic division was a shorthand way. Tabular method is a shorthand way to do this actual integration by parts. So it's kind of set up the same way. You have a u and you have a dv, and you pick u and dv based on the same criteria that I used before. So u would have still been 2x, and dv would have still been e to the x dx. Now, my favorite tabular method problems are when u is algebraic, because it's easy to know when you have a stopping point. You need to take derivatives of u until you get 0. So the derivative of 2x is 2. The derivative of 2 is 0. I'm finished at that point, because if I were to keep taking derivatives, I would just get 0 down the line. Now here for dv, remember you're integrating. So the integral of e to the x is e to the x. Integral of e to the x is e to the x. The tabular method, the setup is always the same. So once you get this established, you need to have signs out in front. This first line is always positive. Second line has a negative. Third line has a positive. We connect these diagonally. 2x gets connected to that e to the x. 2 gets connected to that e to the x. And this isn't important if there's a 0 here, but technically this e to the x gets strung back around with that 0, and I'll explain that in a minute. What this translates to, I'm going to write this answer over here. We have positive 2x times e to the x as our first term. We have negative 2 times e to the x. Now technically here we have a plus integral of 0 e to the x times dx, but that is just plus 0. So I get the same answer. Too lazy to write it on a separate line. Get the same answer as I had before. If this is not 0, which we'll see in some examples later in these notes, then we would have the integral of something, and we'd be able to keep going with that integral. Okay, so let's do another one. We're going to do it both ways again. Yeah, we're going to do the next one both ways. So for number 2, let's go back to the traditional method. Now we have Liate. Remember, if there's a natural log, that's what u has to equal. So u is natural log x. That means that dv is x squared dx. The reason u has to be natural log of x is because we are able to take the derivative of natural log x. It's 1 over x dx. If I would have switched these, I would have had to integrate a natural log x, and we don't have a rule for that, so that's why you have to make u natural log x. Okay, so v becomes the integral of x squared is x to the third over 3. All right, and then remember it's uv minus the integral of voodoo. So equals, I like to put my algebraic term first, x cubed over 3 times natural log x, so I did VU, minus the integral of what? We have 1 over x times x cubed over 3. So I'm going to pull the 1/3 out here. And then x cubed over x is x squared. There's a dx in there. You don't have to pull the constant out in front if that's going to be confusing. It's just how I solved it. So x to the 3rd over 3, natural log x. This integral becomes x cubed over 3 times negative 1/3, so minus x cubed over 9 plus c. All right, what would it look like doing the tabular method? Using the tabular method, I would say pick the same u and the same dv. So the u needs to be natural log x. dv needs to be x squared dx. And when you're doing natural log, there's not going to be a spot where I get a derivative of 0. The first derivative of natural log x is 1 over x. And if I keep going with that, I'm just going to get like negative 1 over x squared, 2 over x to the 3rd, negative 6. So, it's just going to keep going. So when you have natural log, just do one round of this. So just integrate this once. We have a plus and a minus. I only have one diagonal to connect, ln x to x cubed over 3, and then I have a loop here to set up the integral. So the tabular method doesn't really shorten very much for you when a natural log is involved, because if you look at what I have here, I have natural log x times x cubed over 3, so the same first term. And then it says minus, this loop here means you have an integral. So minus the integral of kind of the same thing I just had, right? It was 1 over x times x cubed over 3. So I would still pull a 1/3 out, x squared dx, and then you're going to get to the same thing you had before. See how they're the same thing? So in this case, I would argue that the two methods have the same amount of work, so it doesn't really matter. Now on problem number 3, I'm going to start with the tabular method because this is a much longer problem to do the long way. So let's start with tabular and see where that takes us. Liate says that algebra comes before trig. So u and dv. So u needs to be the algebraic expression, and trig needs to be the dv. The good news about that is when u is algebraic, remember we just take derivatives until we get 0. So it makes things easier because it means that you shouldn't end up with like an extra integral. When you have that 0 on the end, there is no final integral to solve. So that's great. So the derivative of 3x squared is 6x. The derivative of 6x is 6, and the derivative of 6 is 0. Now be careful with your integrals. There's a little bit of u sub going on, right? When I want to do the integral of sine of 2x dx, there's a little u of 2x. So there's a du of 2 dx. So there's going to be a 1/2 that's out in front of the integral. And then the integral of sine, is negative cosine. So it's going to be negative 1/2 cosine of 2x. So there's a lot of little details to think about when you're integrating these little trig functions. And then something similar is going to happen. I'm going to have another 1/2 because there's a 2x u sub going on in this integral. So that's going to be negative 1/4. And then I need to think the integral of cosine is sine, not negative sine. So this stays negative 1/4 sine of 2x. And I do it one more time because I want to stay in line with what I have here. So if I pull out another 1/2, I'm going to have 1/8. The integral of sine is negative cosine. So now this is positive 1/8 cosine of 2x. All right. And then plus, minus, diagonals, being neat and organized with your work is really important here. If you connect the wrong diagonal or if you miss a negative sign or something, if you can't read your writing, that's going to be a problem, obviously. And this gets me right to my answer. So we've got 3x squared times negative 1/2 cosine of 2x. So I'm going to write that as just negative 3x squared. Let's put the cosine of 2x up in the numerator, and then just put it all over 2. That's how I'm going to write it. Then here I have a negative 6x times the negative 1/4. So that's positive 3x over 2. So plus 3x, let's put the sine 2x up there, over 2. And then here I have a plus 6 times 1/8. So 6/8 is 3/4. So plus 3/4 cosine of 2x. Technically, there is a minus integral of 0 right here. 0 times 1/8 cosine of 2x, but that last term is not needed. I keep showing you that because, again, if u is anything other than an algebraic expression, you'll have a number here and you'll have a final minus integral of something and you'll have to solve it. Okay, so instead I'll just write a plus c. Now, if you were doing this by hand, I do want to show, this is the last one we're going to do the long way. I do want to show what would happen if you're doing this with the formula. So let's keep our same, let's see. So if u is 3x squared and dv is sine 2x dx, du would have been 6x. V, we already did this one, was negative 1/2 cosine of 2x. All right, what if we were setting it up the traditional way? Then my answer would start out negative 3x squared cosine 2x over 2. So I have that same first term. And then it's minus the integral. Now, minus the integral of what? 6x times negative 1/2. Why don't we pull the constant out of this? 6 times negative 1/2 is negative 3. And the minus is built into the formula, so that's going to become plus 3. Then I have x cosine of 2x dx. Now this integral that I'm supposed to be simplifying, this still requires integration by parts because u sub would not work with this x out here. So I have to do another round of integration by parts, and my u is different. My u is now just the x. Du would be dx. dv would be cosine 2x. V would be the integral of cosine of sine, and with u sub there would be a 1/2 sine of 2x. All right, so let's look at that. First term is the same. There's a 3 out here. So when you do integration by parts again, the uv minus integral of voodoo, there's a 3 in front of each of those. So I'm going to put 3 outside of brackets here. Uv is 1/2 x times sine 2x. That's a good sign, right? Because that, when I multiply by 3, matches my second term. Minus the integral of voodoo. So minus, let's pull this 1/2 out. 1/2 sine of 2x dx. Okay. What about this integral? It's not integration by parts anymore. It's just a trig integral with a little bit of u sub. Okay, so we're almost there. I'm going to write down my first term. Distribute this 3. Distribute the 3 through one more time. Now what about this? So this is minus 3 over 2. You're going to have another 1/2 coming out from the u sub here. So, so where am I? So minus, oh wait, actually, hold on. Before I get ahead of myself with the signs. The integral of sine is negative cosine. So I'm going to have, even though I have a minus 3/2 right here, it's going to get multiplied by another negative 1/2 when you get the cosine of 2x to come out. So we do finally get to a place where right here I have plus 3/4, where I have plus 3/4 again. I would probably write more steps if I had a little bit more room for this, but so that I don't make that mistake, I really only caught that because of my previous answer. So, you know, I wouldn't try to do all of this in your head. I mean, you can, but it's, if you have more room, you can write things out a little bit more clearly, especially when you're doing homework. All right, now I'm going to stop this video here and then continue it later because I'm out of time for these last three. When it says choose your method, I would always choose tabular. We're definitely going to need to talk about number 5. So anyway, come back and watch the second video, especially for explanation on number 5.